Hello and welcome to this video on top 25 DBMS interview questions with answers. If you're in college, you know how crucial DBMS concepts are for technical interviews. Let me ask, how many of you have faced questions about normalization form or concepts like primary key and foreign key during the placement drives you have been part of? I'm 100% sure that at least once you would have gone through these questions. As a computer science grad or a pass-out student, I can tell you whenever I appeared for an interview, I was at least asked a few questions about database management system. No interview went without the DBMS interview questions. If you're wondering about the reason, consider this. Today, if you go anywhere, if you explore any business function, be it sales, marketing or development, everything is fueled by data. Data is everywhere, and obviously in order to store it, you need something called as database management system. I hope this clears your doubt about the importance of DBMS. Alright guys, so after understanding how important DBMS interview questions are, I went ahead and studied hundreds of interviews that our Intellipaat learners had appeared for. While I was doing this activity, I found out some set of hot questions that recruiters often throw at the candidates. So guys, make sure that you're keeping your notebook and pen handy to make the notes and get ready to ace the interview questions around the DBMS concepts. Let's look at the very first question. What do you understand by DBMS and state its application? So imagine having a vast collection of data like student record, restaurant menu or even your favorite movies and needing to organize, access and update it effortlessly. That's where a database management system or DBMS comes in. So DBMS is a collection of programs that keep everything sorted, secure and easy to retrieve. But how does it really work? With DBMS, you can either create database, insert or update information and even run queries to extract specific data like searching for all the restaurants with the highest rating. Unlike old file system, it avoids duplication and ensure consistency. Now talking about the application, DBMS is everywhere. From bank tracking transaction to e-commerce sites, managing inventory, DBMS is like everywhere. It provides backup and recovery, restricts unauthorized access and makes data processing fast. Tools like MySQL, Oracle and Amazon SimpleDB are some popular examples. Moving ahead with our next question, which is what do you mean by primary key? So imagine you're managing a library and each book has a unique ID number that helps you identify it instantly, no matter how many similar titles or author exist. That's exactly what a primary key does in a database. It's a column in a table that uniquely identifies each records, ensuring there is no confusion or duplication. For example, in a table of student record, the student ID column could be the primary key. Even if two students have the same name, their unique IDs like IDs 101 and 102 help differentiate them. So primary key helps keep your data organized and reliable. Moving ahead with our next question, which is what is the difference between unique and null constraint? So in relational databases, both the unique and null constraint play important role in maintaining data integrity, but they serve different purposes. Now talking about unique constraint, it ensures that all the value in a column or combination of column are distinct. What I mean by this is, no two rows can have the same value in that column. However, unique constraint allows only one null value in a column. This is useful for enforcing uniqueness without preventing missing values directly. For example, a column like citizen ID can have unique values for all rows, but one null value is allowed for cases where the information is not available. Talking about the null constraint, it controls whether a column can have null values which represent missing or unknown data. When a column has not null constraint, it ensures that every row must have a valid not null value in that column. So in short, you can say that unique constraint ensures distinctness, allowing only one null, while the null constraint enforces the presence or absence of values. Moving ahead with the next question, which is what is the degree of a relation? So in DBMS, the degree of relation refers to the number of attributes or columns in a table. It simply tells us how many field or pieces of information each record or rows in the table can hold. For example, if a table has attribute like student ID, name and age, its degree is 3 because there are 3 columns in the table. And here's the breakdown. A table with one column is called unary relation. A table with 2 columns is called binary relation and a table with 3 columns is called ternary relation and so on. So think of it as a width of the table. The more attributes, the higher the degree of relation. Understanding the degree helps in designing efficient databases and writing queries accurately. Moving ahead with the next question, which is differentiate between logical database design and physical database design. So logical and physical database designs are two crucial stages in database development, each serving a unique purpose. Talking about logical database design, it focuses on what data should be stored and how it should be organized conceptually. It defines attribute, entities, relationship and constraint without worrying about how the data will be stored. For example, a student table might include fields like student ID, name and age with relationship to other table. It's more abstract and platform independent, making it easier to adapt for changing business needs. Talking about physical database design, on the other hand, deals with how the data will be stored in the system. It specifies data storage format, indexing, partitioning, and access method. For instance, dealing whether to use a hard disk or SSD or how to index a table for faster queries falls under physical design. In short, logical design is about structure while physical design is about the implementation. Both ensure efficient database performance and adaptability. Moving ahead with our next question, which is how many types of databases languages are there? So database language refers to the specific type of command or instruction used to communicate with database. It helps you to create, manage, update and retrieve data from database. So we can say that it is like a set of tools that help you talk and work with the data stored in your database. Talking about the database language, firstly talking about data definition language or DDL, which is used to define the database internal structure and pattern. In this we have commands like create, alter, drop, truncate and rename. Secondly, we have data manipulation language or DML, which is used to manipulate the data in database by using different set of commands like insert, update, delete. And third, we have data query language, which helps fetch the data using select statement. So that's all about this question. Moving ahead with our next question, which is what are indexes? So indexing in DBMS is a technique used to quickly locate and access data in database, improving query performance by reducing the number of disk reads. It works like a book's index pointing to the location of specific data. Indexes are created on columns that are frequently searched or sorted. They use a search key, usually a primary key or a candidate key, and a data reference or a pointer that stores the address of the data on the disk. While indexing speeds up the data retrieval, sorting the data isn't mandatory. Commonly used index include primary, unique and clustered index. Talking about our eighth question, which is what is the difference between where and having clause? Where and having clauses in SQL are both used to filter data, but they serve different purposes and operate at different stages of query execution. Talking about the where clause. So it filters row before any grouping occurs in the query, and it works on the individual row of data and cannot use the aggregate functions like sum or count. For example, you can use where clause if you want to retrieve orders where the price is greater than 100. A simple query for this can be select star from the order where price is greater than 100. Now coming to having clause, it filter group after the grouping is done and is specifically used to aggregate function to apply condition on the group data. For example, you can use having clause to retrieve products where the total sales exceed 500. And the query for the same will be like select product ID, comma, sum of the sales. You know the sum is an aggregate function from orders group by product ID having the sum of the sales greater than 500. So in short, we can say where is used to filter individual rows and having is used to filter the group data. Together they ensure precise data selection in SQL. Moving ahead with our next question, which is what do you mean by transaction? A transaction in a database management system is a sequence of logically connected operations that are treated as a single unit. So basically these operations involve reading, writing or modifying data in the database. Transaction ensure that a database remain consistent, reliable and free from errors, even during unexpected failures like power outage or hardware issues. For example, when you transfer money from one bank account to another, the transaction involves two main steps. Firstly, deducing the money from one account and secondly, adding it into the other account. Both steps must either complete successfully or not at all happen to maintain the accuracy. So the key operation includes read, write, commit and rollback. Transactions are essential for data integrity and consistency in modern systems. Now talking about our last question, which is what do you mean by query optimization? So ever noticed how some app loads super fast while other takes a lot of time? That's because of something called as query optimization in database, which is like finding the fastest route to get things done. So in simple terms, we can say query optimization is about finding the fastest and least resource heavy way to fetch the data you need. The DBMS looks at all possible execution paths for a query and chooses the best one based on the factors like speed, memory uses, and CPU load. Talking about its importance, the goal of query optimization is to reduce the system resource required to fulfill a query and ultimately provide the user with the correct result to set faster. So how it does that is, firstly, it provides the user with faster result, which makes the application seem faster to the user. Secondly, it allows the system to service more query in the same amount of time because each request takes less time than unoptimized query. Thirdly, query optimization ultimately reduces the amount of wear on the hardware, example disk drive, and allows the server to run more efficiently. For example, lower power consumption, less memory usage. So query optimization keeps things running fast, efficient, and user-friendly. So starting up with the 11th question, which is difference between file system and database management system. Okay, so a file system and a database management system are the two distinct methods for managing data, with each having its unique characteristics. So talking about the file system, so file system is a way of organizing files in directories and retrieving files in storage medium like a hard disk. It groups files into subdirectories to make file retrieval simpler. Talking about the features of file system, you can see here is it organizes files in directory. It has high redundancy due to file duplication. Talking about backup or recovery, it has no inbuilt backup or recovery tool. It lacks efficient query capabilities and it's very less consistent when it comes in data handling. Talking about the security, it has limited security features and of course, due to all these things, it's less expensive. So some of the popular examples of file system includes NTFS or EXT, which is extended file system, and new technology file system. Coming to this database management system, as you all know that database management system is a software which is designed to manage and organize large amount of structured data. Okay, and it stores data in the form of tables with rows and columns. Now, if we talk about example of DBMS, it includes MySQL or Oracle. And talking about the features, it uses table to structure data, it minimizes the redundancy, it provides very good backup, and it offers optimized query processing with data consistency and advanced security mechanism. And because of all these features, it is higher in cost but offers more functionality. So moving ahead with our next question, which is what is a ER model in DBMS? So the entity relationship model is a visual representation of database structure focusing on like entities, attributes, and relationship. So you can say that the entity relation model is a model for identifying entities to be represented in the database and the representation of how those entities are related. Okay, so you can say there are three components in ER model, which is entity, attributes, and relationships. Okay, so coming back to entities, so all the real world objects which are represented in database are considered as entities. For example, book, member, librarian, or anything which you can see from your eyes, or any object. Coming to attributes, so you can see, suppose this is book, this is an entity. Okay, now coming back to the attributes, so book ID, okay, all the properties of this book, book name, okay, author, all are its attributes. And what is the relationship? Relationship is connection between the entities. So how two entities are being connected is called as relationships. As we previously discussed, the ER model has three components: entity, attributes, and relationship. So talking about a very simple example to demonstrate this, suppose you have this employee, okay, this diamond, it represents the relation, and this rectangle represents the weak entity. So for example, talking about this employee, it's an entity, this has a relation, okay, has a relation with its dependents. So here it will come dependence. Okay, now from this you can easily make a table in DBMS. So we can say that ER model helps in making the tables in DBMS. So these all the representation will be converted to a table. So entity can be a strong entity, weak entity, and attributes can be of key attributes, composite attributes, multi-valued and derived. Relationships, one-to-one, one-to-many, many-to-one, and many-to-many. Moving ahead with our next question, which is difference between entity, entity type, and entity set. Okay, as we previously discussed that a entity is a specific object in real world with independent existence, means it does not depend upon any other entity or any other factor. Okay, so any particular row is an entity. Okay, so this particular row, like 1 and this John having ID 1 is an entity because it represents a single row or a record in a table. Okay, so coming to entity type is a category or a schema defining the structures of entity. Okay, so it represents the name of a table. For example, the name of this table is student. Here are, you can say, some values 1, 2, 3, name X, Y, Z, age, A, B, C. Okay, so the schema of student table with attributes like ID, name, age, just the overall structure with a name represents the entity type. Now coming back to entity set. Now entity set is a collection of all the entities. Okay, for example, here is ID 1, name John, suppose age is 16, ID 2, name Ram, age 18, ID 3, Kiran, age 20. So all these 3 records you can see here, all the 3 records in this particular schema comes under the entity set because it represents all the row or records of a table. Got it? Okay. So moving ahead with our next question, which is what do you mean by generalization and specialization in DBMS? So generalization is the process of extracting common properties from a set of entities and creating a generalized entity from it. Okay. For example, faculty and student. So there are 2 entities which can be generalized into a bigger entity. For example, faculty is a person and student is also a person. So generalization is a bottom-up approach in database design which combines 2 or more entities with common attributes into a high-level entity. Okay, now coming back to specialization. So specialization is an abstraction mechanism where a relationship and entities are treated as high-level entities, and it is also known as top-down approach. Okay, so for example, employee is a tester or can be a developer. Okay, so you see it follows top-down approach because this employee is being divided into 2 fields. So basically in specialization, the entities are divided into sub-entities based on their characteristics, and remember they should have some common properties between them. Okay, so moving ahead with our next question, which is what do you mean by relational algebra? Okay, so relational algebra consists of certain sets of rule or operation that are widely used to manipulate and query data from relational database. Okay, so it's a procedural query language providing a foundation for SQL which defines operation to transform input relation into output relation. Okay, and what's the purpose? It efficiently manipulates the data for retrieval and it uses mathematical symbols and not English keywords, which can help you understand better what's going on behind the scene. Now talking about the key operators, we have selection, projection, union, set difference and Cartesian product. So talking about this selection, so suppose you have a table, okay, with 3 columns A, B and C and certain values, suppose 1, 2, 3, 4, 2, 2, 2, 3 and 4, 3, 3, 4. Okay, so if you have applied selection, so selection symbol is this sigma. So what it will do, it will basically filter out rows from given table based on certain condition. Okay, so if you have put this sigma c greater than 3, so what it will do, it will select all the tuples or the row which have c more than 3. Okay, so you see the more than 3 values are this one and this one. So it will filter out and it will be giving like ABC 1, 4, 2, 3 and this 4, 4. So selection operator will do this. So this selection operator operates basically on row. Similarly, projection operators of relational algebra works on column. It basically allows you to pick specific column from a given relation. Okay. So projection symbol is pi. And one of the important feature of this projection is by default projection removes all the duplicate data. Similarly, union. As you all know, union operator is basically used to combine the result of two queries into single result. Okay. Then we have this set intersection. So set difference basically provide the row that are present in one row and is not there in another row. In maths also you must have read about this. So A minus B will give all the elements present in A but not in B. Okay, I was telling about set difference. Now coming back to set intersection. So set intersection will give everything present in column A and column B, all the commons. Now coming back to Cartesian product. So Cartesian product or cross product basically is represented by X and it combines every row of one table with every row of another table. So A, B, C, D, suppose you have 4 rows. So every row of one like this. Okay, this is the Cartesian product. And then come the rename operation. It basically renames the table name. Okay, so that's all for this question. Moving ahead with our next question, which is what do you mean by normalization? So this is one of the very important question which are usually asked in all the interviews. So you can go on by saying that normalization is the process of organizing data to reduce the redundancy and dependency. And what purpose it solves? It ensures data consistency and improve database efficiency. And how does it work? It works by dividing a larger table into smaller and related table. Okay. So as you can see here, we have 1NF, 2NF, 3NF, 4NF and 5NF. In 3NF, we also have BCNF, boycott normal form. So now talking about the 1NF, this is the most basic level of normalization, and in 1NF, each table cell should contain only a single value and each value should have a unique name. Okay. So for example, you have a table here. Okay. Name and phone number. Okay. Suppose X is there and Y is there. Okay. So X can have 2 phone numbers. Okay. And this Y similarly can have 2 phone numbers. So what it does, that it violates the rule of normalization because a table like X cannot have 2 values. Okay. So maybe you can convert this table into 1NF, and after conversion what it will look like, it will be like X having its first number here, second number here, Y is having first here and then second here. So each table should contain the atomic values. Similarly, second NF. So a relation will be in 2NF if it is in one normal form and all the non-key attributes are fully functional dependent upon the primary key. Okay, so no such value or no such field in a table should be there which is not dependent upon the primary key. Okay, coming to 3NF. So 3NF, a third normalization form, it builds on 2NF, meaning a table should be in 2NF by requiring that all the non-key attributes are independent of each other, which means that each column should be directly related to the primary key and not to the other columns in the same table. Okay, so 2NF should be there and no transitive dependencies should exist. Transitive dependency meaning if A is there to B and B is connected to C, then A should not connect to C. Coming to BCNF or boycott normal form, which is a stricter form of 3NF, which ensures that each determinant in a table is kind of candidate key. So in simpler words, we can say that boycott normal form ensures that each non-key attribute is dependent on the candidate key. Okay, so coming to 4NF, which is a further refinement of boycott normal form. So a relation will be in 4NF if it is in BCNF and has no multi-value dependency. Similarly, 5NF is not that asked in interviews, but to your information, a relation is in 5NF if it is in 4NF and it does not contain any join dependency. And joinings should be lossless, meaning that no values after joining table should be lost. Moving ahead with our next question, which is explain the difference between clustered and non-clustered index. So in the start, we already discussed that index is a disk-based structure which is linked to a table or a view that facilitates quicker row retrieval. Okay. So what do you mean by clustered indexing? So in clustered indexing, data is stored and sorted physically in the table. Okay, and only one cluster index per table is there, which results in faster for range queries. Okay, so if I were to explain clustered indexing in detail, suppose you have a schema. Okay, suppose you have this schema, create table, a phone book. Okay, and it consists of course last name, first name, phone number, and your data type, varchar. Okay, size. Okay, so and suppose you have 4 records for this particular schema. Suppose you have 4 records here, like K, last name, suppose Kumar, here Ram, and here his phone number, 88 something. Okay, suppose here you have something Agarwal, suppose name is Varun, and you have phone record here. Similarly, Mishra, something name and phone number. Again, Shri, Shash, and this phone number. And what will happen in cluster indexing? The rearrangements will be done like this. A pointer will be there, it will be pointing to this, and all these 3 records will be sorted in ascending or descending order based on the requirements. So you have seen here A, it will come here, then K, then M, and so there will be one schema here, then other schema, repeat, then other schema here. Okay, and then this will be organized to a bigger form. Okay, so this is how the cluster indexing works, that it simplifies or reorders by pointing back to like this. Okay, and on what basis they are sorted? So they can be sorted on the basis of primary key or any other condition which you specify. Now coming back to non-clustered indexing. So the non-clustered index is similar to the index of a book. Okay, so you all have searched for specific topics or title present in your books, right? And how do you search? Just think if index wouldn't be there, how difficult it would be to search for a particular keyword by looking at each and every page. So similarly, to tackle that problem in DBMS, non-clustered indexing is present. So talking about the key points, so multiple non-clustered indexes are allowed per table, and which is ideal for searching specific columns, and of course is slower than the cluster index for retrieval. Okay, so the data is stored in one place and the index is stored in another place. And since the data and non-clustered index is stored separately, you can have multiple non-clustered indexes in a table. So, talking about the example, suppose you have this record pointer, okay, and particular schemas, okay, 1, 2, 3, 4, 5, 6, okay. So this record, suppose, and here you have 5, 7, 1, 4, 8, 3, 6, 2. So the record pointer will be pointing like this. Okay. The index contains the pointer to the data. And you can see here that the copy of this data is the index, not the original value. Okay. So that's all for clustered and non-clustered indexing. Moving ahead with our next question, which is what are triggers? Okay. So a trigger is like an automatic rule, or you can say BTS action that database runs for you. You don't have to tell it to do something happening each time. Okay. It just happens when a specific event occurs. For example, a trigger could automatically update a record, send a notification, or log an entry whenever a new row is added to a table. So you must have heard some people saying that bright light triggered the headache. So triggered is what? The automatic action. Okay. Similarly, taking the example, suppose this is a shopping cart. Okay. So whenever you are adding a new order, okay, +1 you're adding, then in cart or in Flipkart or Myntra, you must have seen that there comes a pop-up notification that item is added to cart, right? What's that? That's the trigger. And why to use trigger? Because it reduces the manual work, it keeps the table synchronized, and it tracks changes automatically. So how do trigger works? Okay, there are basically 3 conditions. Firstly, database action. So a trigger listens for certain actions on a table. So these actions could be insert, update, or delete. Inserting meaning adding new data, updating meaning changing the existing data, and deleting meaning removing the record. So the trigger has a condition that checks if action should actually happen, and if the condition is met, the trigger takes action. If it does not, nothing happened. And then event response. Okay, this will check the action and then this will respond. So once the trigger detects the action, it runs a predefined task such as updating another table, okay, or logging changes for auditing purpose, or sending an alert to the database administrator. So talking about the simple syntax for creating triggers, which is you will write create trigger, okay, and then give your trigger a name, trigger name, okay, then before and after, okay. So this will specify when the trigger will be executed. So what trigger you want to insert, update, or delete, what trigger you want to perform on, specify the table name on which you want to perform your trigger, then for what row you want, suppose for each row, and then comes the trigger body, okay. So this provides the operation to be performed as the triggered is fire, okay. So moving ahead with our next question, which is what are integrity constraints? So integrity constraints are set of predefined rules that are used to maintain the quality of information, which ensures that the data remains accurate, consistent, and reliable in the database. So you can say they act as guideline ensuring that data in the database remain accurate and consistent. So integrity constraints are used to basically protect your databases. during insertion, updating and deletion, and which ensure that data relationship remains valid. So now talking about the types of integrity constraint, we have domain constraint, not null, entity, key, primary key and referential integrity constraints. So I'll be talking about few of them. So what are domain constraint? It defines valid value for an attribute. For example, age must be an integer, not a string. Okay. So if domain constraint is applied here, then here you are inserting 20, 22, 21, 23. Why? Because of domain constraint. It says that age can only consist numerical values and not the values in form of strings. Okay. Not null constraint. It ensures attributes cannot have the null values. Meaning this semester, it can't be empty. Okay. That's not null. Coming to entity integrity, it says that primary key must not be null. So in this case, the student ID, it serves as the primary key, right? Because it's specific and it's unique for each and every record. So it can't be null. So it's a primary key constraint. Talking about referential integrity constraint, it says that foreign key must match the primary key in the related table. For example, this is the student table, right? Suppose this is a student table. So suppose you have another table which is course. Okay. So student ID is there, name is there, and then age is there. So this student ID serves as the foreign key. And what referential integrity constraint says that foreign key must be the primary keys in the related table. So this course table and this student table is related because of this student ID. So what's this saying? That student ID must be a primary key in both the tables. Okay, so that's all for this question. Moving ahead with our next question, which is how is pattern matching done in SQL? So what's a pattern matching? Pattern matching is in SQL is the process of searching for specific text pattern with a columns data. And what we use this like operator for pattern matching in SQL. Okay. So this %, it matches for 0 or more characters and this matches for only one character. So example, if you want to find names ending with Y, suppose we have two names, Mary and Anthony from suppose any table, and you want to find out the name which are ending with Y. So what you will do, you will write this simple piece of code which is select from employee. Suppose you have this employee table where name like %Y. So it will list all the name which are ending with Y. Okay. Or find the names with A as the second character. So what you will do, you will write select star from employee table where name like just one simple dash A% because I want the second character to be A. So the output will be David and Sam from a specific table because in both the names the second character is A. So moving ahead with our next question, which is what is concurrency control in database management system? So concurrency control ensures that multiple transactions run simultaneously without data inconsistency, which helps in increase of efficiency and which maintains data consistency. So concurrency control deals with the interleaved execution of more than one transaction. And what I mean by transaction is a collection of operations that perform a single logical function in a database application. Okay. For example, debit of A or credit of B, the amount deducted and the amount credited in B must remain consistent after this whole transaction is taken place. And how does it is being ensured? It's being ensured by concurrency control. So now talking about some of the problems and mechanism of concurrency control. So problem is a read-write problem or lost updates, and mechanism is lock, shared, two-phase locking or timestamp. Talking about read-write problem. So read-write problem occurs when one transaction updates an item, but due to some unconditional event that transaction failed, but before the transaction performs rollback, some another transaction reads the updated value. So suppose you are having two transactions, T1 and T2. So suppose transaction is happening of debiting and crediting the money. So minus 50 happened from transaction T1. It modified the database. Okay. Minus 50 has been given to T2. But in reality, this 50 has not been debited from T1. Now T2 reads the same value, the same original value. Suppose, say T1 has the original value of 100. Now T2 will read the same value as 100. Thus T2 will be reading the same uncommitted data of T1, which is no longer valid, thus creating inconsistency in the database. So this comes under read-write problem. Talking about lost update problem. So lost update problem occurs when two or more transactions modify the same data, resulting in the update being overwritten. Okay. Again, two transactions, T1, T2. Data is 50. Now T1 is adding plus 10 in 50. It becomes 60. Okay. So database has got, okay, now my value is 60. Now T2 will come. It will also add plus 20. Now base will become, it was 60. Now it will occur 80. So T2 updates the same data based on the initial read and perform the commit. So this will result in the modification of T1 data, because T1 modified the data by 60, but now T2 will again modify the same data to 80. So it will cause a lost update problem in the database. So what's the mechanism? Shared lock. Shared lock is also known as read-write lock, which allows multiple transaction, but you can say it will put a lock that, okay, now this will happen. Now T1 is doing the stuff. Now at the same time, T2 can't update that data. Okay. So that comes under the shared or exclusive lock. Now coming back to two-phase locking. So two-phase locking is widely used technique which ensures strict ordering of lock acquisition and release. And now coming back to timestamps. So timestamp is nothing but a time in which transaction enters into system. Okay. So for example, 1 to 5 seconds, T1 will acquire the system. So at this particular point of time, no other transactions should occur. So that is all for the concurrency control. Moving ahead with our next question, which is, what are the type of keys present in database management system? Okay, so in DBMS, what are keys? Keys are the attributes or set of attributes that uniquely identify records in a table and establish relationship between tables. Okay, so I'll be explaining you this with a simple example. Okay. So this particular table covers all the key present. So super key. What are super key? Super key, you can say key of keys. You must have heard like king of kings. Okay. So super key is like key of keys. So in this particular table, this employee ID, okay, which is helping to identify all the records of this table uniquely, is called a primary key. Okay, coming back to foreign key. So foreign key is a key which helps in determining relation from one table to another. So in this case, DID serves as the foreign key because it helps in the connecting of two tables. So candidate key is the key which consists all the possible columns which are worthy of becoming primary key but are not primary key, and primary key can be chosen from one of the candidate keys. So see, employee ID, employee license and employee passport all can become a primary key, and from this employee ID is being chosen as a primary key. Okay. Any key other than primary key serves as the alternate key. Okay. Similarly, keys helping in determining the columns uniquely, called as unique key. The only difference between primary key and unique key is primary key cannot be null, but unique key can be null. Okay. So I hope you got this, the type of keys present in database. But for your better understanding, here we have the definition also. So candidate key is minimal set of attributes to identify a tuple. Primary key, a chosen candidate key to uniquely identify rows. Super key, any set of attributes that can uniquely identify tuples. Alternate key, a candidate key which is not chosen as primary key. Foreign key refers to primary key of another table. Composite key, a combination of two or more attributes. Okay, so moving ahead with our next question, which is what are the different levels of abstraction of DBMS? So, database system comprises complex data structure. And in order to make the system efficient in terms of retrieval of data and reduce complexity, many of the developers use the term abstraction, which is hiding the underlying details from the user. Okay, so there are three levels of abstraction: physical, logical, and view. So we'll be talking firstly about the physical level. So this is the lowest level, as you can see here this is the lowest level of data abstraction, which tells how the data is actually stored. So it tells the how. So these are accessed by only the database administrators, also known as DBAs, and the task is to manage storage, indexing, backup, and recovery. Suppose we need to store the details of an employee. So block of storage and the amount of money used for this purposes are kept hidden from the users. So user doesn't actually needs to know that what amount of memory is required if we want to store the information about employees. Okay, so moving ahead with logical level. So logical level comprises the information that is actually stored in the database in form of table. So it contains the information of table. Info of table. And these are accessed by DBAs and developers. Task is to define table, relationship, and the constraint. For example, employee table with their attributes like employee ID, name, and department, these all comes under the logical level. So logical level thus describes the entire database in terms of small number of relatively simple structures. Okay, and these are sometimes known as physical data independence. So database administrator who must decide what information to keep in database use the logical level. Physical level consisted of how, this will consist of what. Now talking to the view level in DBMS. So this is the highest level of abstraction and only a small part of actual database is viewed by the users. And it is simplified for user interface to access the data. And who can access it? The end user. And what's the task? Task is to display the data relevant to users based on their role. For example, a manager sees the name and salary, HR sees the name and department and contact info. So everybody sees the requirement based on their respective departments. So the view level of abstraction exists to simplify their interaction with the system. So moving ahead with our next question, which is differentiate between 2-tier and 3-tier architecture. Okay. So when you are building a system that uses a database, the architecture you choose is the key how everything works together. Okay. So talking about the 2-tier architecture, in 2-tier setup, you have the user interface or the client and the database on other side, with the two directly communicating. So there is a direct connection between the client and the database. Talking about the features, of course, because there is direct communication, it's very simple and easy to build. And of course, it's ideal for small application. For example, contact management, reservation system. Talking about the drawbacks, it is less secure because client has directly access to the database and performance issues as user increases. So as the user will increase, the performance will degrade. So the interface is usually located in the user's desktop and database management system are usually in a server. Okay, now talking about the 3-tier architecture. In 3-tier architecture, the application logic or process lives in the middle tier. This is the logic. And it is separated from data and the user interface. So application layer here acts as medium between client and the database. Talking about the features, it's more secure because users don't directly have the access to the database, and it is ideal for complex system, for example, web application. But the drawback here is it requires more effort to build and maintain because one has to maintain the application server. So 2-tier database is a client server architecture, CLA, and it is web-based application. Okay. So I would recommend you guys to go through the differences because it's often asked in the interviews. Moving ahead to our last question, which is there's a table where only one row is fully repeated. Write a query to find a repeated row. Okay, so you see here is a table with name and section, and you see that one row is fully repeated, like ABC and ABC, section CS1 is coming twice. So what query we can perform is, we can select name, section, okay, name and section, because we want both the column from table. Okay, group by name, we'll group this by the name, section also, having count star greater than 1. So after grouping, we will have ABC as 2, BCD as 1, CS1 as 2 and CS2 as 1. So we'll list down only the row which will have the count greater than 1. So this has the count greater than 1 and this also has the count greater than 1. So the answer will be ABC CS1. So this is the query you will perform in order to find the repeated row. So that's all from my side. If you have liked the video, kindly hit the both like and subscribe button for Intellipaat's YouTube channel. Thank you and see you in the next video.